Hello, everybody, and welcome to Ask an Engineer, live from New York.
Yes, hello, welcome. It's me, Lady Ada, and with me is Mr. Lady Ada, and we're here at the Adafruit factory in Manhattan, in New York, downtown in Soho.
We're a USA manufacturer making
right.
electronics in New York City, USA.
Not only that, but the location we are videoing from right now is where we do the manufacturing, and design, electronics, testing, all the procedures, the shipping, the QA, it all happens here.
You sit there, and the means of production are over there.
Yeah, you can even kind of see the oven maybe.
Oh, yeah.
But this is where how the magic happens. And we're going to be talking about that magic today on the show. What's
That's right.
on the show tonight?
It's a magical hour of electronics and
Yay!
sharing. Okay, on tonight's
Magic.
show, the code is Marigold. 10% off in the Adafruit store all the way up to 11:59 p.m., except for gift certificates. And what else, Lady Ada?
We don't have software, but Ada Box subscriptions.
Ada Box subscriptions, that's right.
Okay. Whew, pass that test. I get to stay another week on the island.
That's right. All of the electronics you purchase help us, Team Adafruit, right here in New York City.
Yay.
Show and tell. People around the world sharing and showing their projects. And cats.
And Cybercats.
Packet the Mailbag's going to stop by, read some of your letters to us. Time travel, a look back in the world of makers, hackers, artists, engineers, pioneers, and more. Some made in NYC, some factory footage. Some IoT, specifically Adafruit IO news, 3D printing, new products. We'll answer your questions, and then this week we have a special top secret. Oh yeah, from the vault. Trivia question where you give away something, all that and more on
Dun, dun, dun.
Ask an Engineer. Okay, Lady Ada.
You know it.
Yeah, we're here all week.
Well, we're here now for the entire hour.
That's right.
Then we're going to go eat some food.
Yeah, but we're still here all week. Okay, so let's get started. Let's tell some folks a little bit of a reminder. Said it before, say it again, Marigold's code. You're watching Ask an Engineer, Wednesdays, 8 p.m., and Show and Tell is 7:30 p.m. We just did that.
Set your watch to it.
We have same-day delivery here in New York City. If you check out before 11 a.m. and your zip code that we ship to, you can. But no matter what, if you're in the continental U.S., $200 or more, you get free UPS ground. So, without further ado, as they say...
Ado.
Lady Ada...
But I want more ado.
I know. Maybe later. So, as seen on the Show and Tell, people showed their projects, things that are important to them.
I wrote them down.
What was on the show?
Yes, we had a bunch of people, some new, some familiar faces. Starting off with Noah and Pedro, they had the MIDI cap touch controller from last week's video, which is really cool, like hexagon capacitive touch drum machine that does Bluetooth MIDI. Looks really neat. And then, so they showed that off and they demoed it. And then this week's project is LED cubes for Lego. One of the things that kind of proved to me and others that 3D printing was really working out is you could make stuff that would snap to Lego pieces, like, brick
cool.
compatible, as it were. And so this week they have cubes that glow with LED light. And so they showed off some really neat Lego sceneries that they built. And of course they have a video and guide for that. We'll talk about it soon. We have Euroscott. It's a European version of Scott. He's in Barcelona, like he said he would be. And he's meeting up with all sorts of cool European and Spanish makers. And this week he's been playing with, he did a CircuitPython release. He's playing with CircuitPython and Circuit Playground. We're kind of making sure that all works as a good playground for Python. He got some NeoPixel code working on it and temperature demo. And he's kind of studying, how can we make demos that are really evocative and fun. Out
of the box fun in 5 minutes.
Fun, and easy to adjust. Adapt.
What happens now is you get a thing, you have to download a bunch of software, it doesn't work. There's some Java thing, you have to restart, you have to get the right cable, you have to do all these things. We're getting rid of all of that and only having the fun part with CircuitPython.
Yeah.
Okay.
Okay, so that's that. And then we also have Tony D from Adafruit Northwest. He's also doing CircuitPython NeoPixel stuff. We're all doing this together. He has a video from last week. Check it out if you're interested in using NeoPixels in CircuitPython. It's easier than ever, and you can edit right on the device, which is so cool. One of my favorite things about CircuitPython. And then, okay, that's the Adafruit peeps. Then we had a couple of visitors. We had Richard, who is now at the Living Computer Museum.
I have a pin.
Nice.
Thank you, Carter Nelson.
That's a nice pin. Yeah, people love this museum. It's in Seattle. Where is it?
Yeah, Washington State.
Sorry, I don't think I've ever been to Seattle.
Nope.
So if you are in Seattle, unlike me, you can go to the Living Computer Museum, and they even have an IoT section now where people can explore and have fun with Internet of Things. They've got some Hue lights and Home Assistant and like some buttons and the big sign, and Richard is there, and he will helpfully show you all about Internet of Things and what does it mean and how is it going to take over your life in good ways and bad ways. So check that out. They've got demos and more at the Living Computer Museum, a great resource. And also Andrea and his young assistant Matthias showed up. They are in St. Louis, and Andrea teaches classes on programming microcontrollers, which is cool. He says he really likes that. But a bunch of his students and him, I think the student, I don't know exactly who it was, but a bunch of kids that he knows put together a weather balloon that they sent into the sky. It was a pie in the sky, they said, and it had a Raspberry Pi 2, and they had 3 cameras. So we had Raspberry Pi cameras and like maybe some other cameras to take photos once a minute. And then they used a LoRa plus GPS hat on the Raspberry Pi to transmit data and location information. And they also had an APRS beacon hat. So he has I guess he has a ham radio license. And because of that, he can set up the Raspberry Pi to use APRS, which is a ground network of repeaters, to transmit the location of the balloon. So after they sent it up, it was a successful launch. They said that it went up, 65,000, 80,000 feet?
Yeah, it was up there.
It was pretty high up, and went negative 60 degrees centigrade, so extremely cold. Survived the trip, and then landed 80 miles from the house. So they ended up finding it, getting all the photos back, and he showed up some of the really cool photos, including ones that showed the curvature of the Earth.
Yeah, and one other thing to mention, that in addition to our As Seen on the Show and Tell stickers that we send out to people, this is the first time that I've been able to send out a high altitude balloon badge.
Yeah.
It's a iron-on badge.
Yes.
So that was really cool. Okay. Well, all participants on the Show and Tell get As Seen on the Show and Tell sticker, except for Andreas. He also gets a high altitude balloon badge. That's right. That's what we did. Okay. This is part of our Adafruit Live series. We do stuff all week, every week. Lady Ada, what were some of the things that you showed and shared on Desk of Lady Ada recently? We had samples.
Okay, we had a bunch of sample. We had a sample Sunday and a sample Tuesday.
Yeah.
I did some more Q-Touch hacking.
Yeah. It's all available on youtube.com/Adafruit, and you might be able to see us playing around with
a lot of samples.
the oscilloscope, a talking oscilloscope.
Yeah, definitely. Okay, yeah, we had Friday, I think Thursday or Friday was, or Saturday was the Q-Touch, and then we had sample Sunday, and then we had sample Tuesday. So how do I pick and choose the things that go into the shop? Well, if you watch these videos, you will know.
That's right. Desk Tony D. Tony's doing a bunch of stuff with CircuitPython. CircuitPython is our easy-to-use educational version of MicroPython, optimized for Adafruit educational hardware and accessories.
It's in beta.
It's in beta. Not only that, we have Blink of the Snake.
Aww.
But more importantly, we have Tony D, who does these amazing videos, and he did the Arc Reactor, and he used NeoPixels and
Circuit Playground on CircuitPython, an upcoming version of Circuit Playground that can run Python. So right now we're just playing around with projects and ideas, trying to make sure that all the things that we think people want to do, because it's a pretty radical departure from Arduino land.
It is so different, and to me it reminds me of when you go from phones with buttons to a touch screen. Or when you start using like Dropbox, it just automatically is doing stuff for you. It's helping you.
Yeah.
And what's neat is you don't need any IDE. You can just double click a file, you save, and the code's already running. That's it. There's nothing else. Works on low-cost computers. We're getting a lot of these Circuit Playground devices to underprivileged kids because there isn't a big budget per student. So this is like $20 or less.
Yeah, and it's neat because you can like write code on any platform. You know, you don't even need to download any software a lot of the times. You just edit the code directly on the device. It's really weird, really interesting.
It's super cool.
Super cool. All right, so check out Tony D's awesome videos if you want a taste of what it would be like.
And speaking of Circuit Playground, we have existing projects with our AVR version as well, and Erin has one she's going to show.
Okay, take it away.
Circuit Playground is a really fun, really easy to use microcontroller that's a great way to add sensors and interactivity to your project without a whole lot of fuss and soldering. It's got a built-in motion sensor, a sound sensor, a light sensor, and a temperature sensor, as well as a built-in speaker and 10 neopixels, ready to use right out of the box. I'm just starting to explore the fun things that this board can do. Today we're going to focus on the motion sensor. I was inspired by Becky Stern's Sparkle Skirt tutorial, which uses a Flora and an LSM303 motion sensor to make the lights in a skirt twinkle when you move. This is a really popular guide, and I have a lot of friends who really want a sparkle skirt, but the soldering is a little intimidating, and using a separate sensor and a board can be difficult. Using the Circuit Playground makes this project a lot easier. Before you start, you'll need to install some software on your computer. We'll be using the Arduino IDE with the Circuit Playground library. Installation is covered in the Introducing Circuit Playground guide. See the links in the comments. You'll need to install Arduino, then the Adafruit board support, and then the Circuit Playground library. Once your software is installed, come on back. I'll wait. Once you've got everything installed and your computer can talk to the Circuit Playground, it's time to start playing with the sensor. Plug your Circuit Playground into your computer and select the board in the Tools menu. Then select Circuit Playground as the port. Now, go find the Circuit Playground examples in the Library Examples menu. Open the Hello Accelerometer example code. Upload it to the board. Now, open your serial monitor in Arduino. The serial monitor gives you feedback from the board so you can test your code at a really basic level and make sure everything's working. If all is well, you should see some numbers scrolling by in this window. You'll see values for X, Y, and Z. These represent the 3 different directions this board can move. Keeping the Circuit Playground plugged in, pick it up and move it around a bit and watch and see how the numbers change. This is still kind of a lot of info to process, so let's simplify it. First, think about how the board will be mounted in your project. I plan on sewing it into a pocket in my skirt with a USB port facing upward and the board in a vertical orientation, so that's how I'm going to hold it when I play with the sensor. Let's simplify even more. Go into your code window and comment out all the serial commands that talk about Y and Z. We'll just focus on X for now. While you're in there, change X's second serial print to a serial print line command. This will make a new line for each value in the serial monitor so it's easier to read. Upload the code again. Take another look at your serial monitor. You'll see just one reading for X appear each second. Play around with moving the Circuit Playground through space again and watch what happens with the value on the screen. Try moving the board in all 3 dimensions and see which one changes X the most consistently. With the board oriented the way I want it in my project, it looks like X changes the most dramatically when I turn the board clockwise or counterclockwise. Go back to your code and uncomment only the Y lines and upload again. Then get a feel for which axis of movement the Y direction controls. Looks like it's related to the board twisting left to right. Try once more with Z. Z appears to control the back and forth motion. So, the data for X will measure my side-to-side motion, like when I do cartwheels. Y will measure whether I'm spinning around in circles, and Z will be able to tell me if I'm doing forward bends or back bends. I want to use a combination of all 3, so the lights come on whenever I move any which way. Rather than starting from scratch and having to do my own math, I've borrowed some code from the Sparkle Skirt guide and modified it to work with this Circuit Playground. Upload this code to your Circuit Playground and watch the serial monitor as you move the board around. The word twinkle will appear whenever the board moves far enough. Change the move threshold number to make it more or less sensitive. Lastly, let's get out of the serial monitor and into the real world. We can easily make one of the neopixels on the board twinkle whenever the move threshold is reached. Open another example sketch, Hello Neopixels. We'll grab the code for pixel 0 and copy it into our twinkle loop. We'll also add the clear pixels line to the beginning of our loop function, so the light goes back off again. And we'll shorten our delay so that everything happens in real time. Upload the code again and move your circuit playground around to make the light twinkle. The applications for this are endless with a little creativity. Check the Adafruit Learning Center for the next steps and more code samples to get your project twinkling.
Okay, and we have a video from JP, or as we like to call him, John Park. And this week is, do you remember what his video is?
This one is about neopixel level shifting.
Oh, that's fun.
Yeah.
We should watch it.
It's a handy tip.
Let's watch it.
Hi, this is John Park for Adafruit Industries, and I wanted to talk to you today about using a level shifter so that you can get a microcontroller that runs on 3.3 volts to talk to neopixels which run on 5 volts. So what's all this about logic level shifters anyway? Well, what happens is we have a power and ground coming from a power supply. In this case, I've got a 5 volt and 10 amp power supply, pretty beefy one, that can run the lights on this neopixel strip. But there's a third pin on the neopixel, and that's the data line. That's the control coming from our microcontroller telling each pixel what to do, what color, what brightness, when to light up. And the problem is when these 3.3 volt microcontrollers are trying to talk to the data pin on the neopixel, you can end up with some pretty strange results. I've had everything from dim pixels to dead pixels to the wrong color showing up, and it's kind of frustrating until you realize that you can get a translator to sit in the middle between the microcontroller and the neopixels. So the level shifter has this one job in life, really. It takes the input coming from, in this case, the 3.3 volt data line, and it translates that to an output that this 5 volt data line can understand. The connections you need to make between these are pretty straightforward. What we have are reference voltages on either side. So the microcontroller talks to the level shifter and says, here's a 3.3 volt reference. And the neopixels on the other side of the level shifter say, hey, here's my 5 volt reference. Now the level shifter knows how to translate or which languages it's talking on either side. The other connections that we're going to make are a common ground, and then any of the channels that we want to communicate this translation between. In this case, I'm using this bidirectional level shifter that has 8 channels, so that means we can talk between 8 different devices. What we do is take an output pin coming off of the Feather microcontroller, in this case I'm using pin 6, and it goes into the A1 of the level shifter. Then the B1 of the level shifter goes out to the neopixels to do the translation. The connections we have on the board are this Adafruit Feather M0 with a LiPo battery, and then we're tying it to ground, and we're running the 3.3 volt out from the Feather to the reference voltage, or VCCA, on the level shifter. The level shifter is also tied to ground, and we are running the pin 6 from the Feather, which is the data line telling the neopixels what to do, out to this A1 channel. That's the first of the 8 channels on the level shifter. We have power coming from a 5 volt 10 amp wall adapter, and that's running through this plug to this rail on the breadboard. And we're also using a fairly large capacitor to smooth out that power and that is connected near the source between the power and the ground rails. The power coming off of that is running both to the NeoPixel, so we have the 5 volt and the ground coming from this power supply running to the NeoPixel strip, and we're also using that as the reference voltage on this side of the level shifter. So that's running to the VCCB input. Then we have that pin 6, which came off of the feather and is going into the channel A1, being translated from 3.3 volt to 5 volt, and then running out this B1 channel into the NeoPixel strip so that the communications are understood by the strip. One way to make your circuit a little more permanent is to move from a breadboard onto a perma-proto board. Now the perma-proto board is laid out exactly the same way as the breadboard. So this means you can keep the same layout you had, move things onto this board, but now you'll be able to solder your connections instead of having wires that can fall out. So there we have the level shifter helping our 3.3 volt microcontroller talk to our 5 volt NeoPixels, and we've moved everything off of the temporary breadboard onto the much more permanent perma-proto board. I'm John Park for Adafruit Industries.
Okay, it's time to read your letters. Here's a packet. So every week at State of the Fruit, we read your emails, letters, whatever to us,
Tweets.
to everyone at the company.
That's right.
And this week, I'm just going to read a little bit of it because it's a long one. You can look at the blog. Dear Lady Ada and Mr. Lady Ada and all the Adafruit Industries, it's your fault. Yep, and don't even try to deny it. You have a new loyal customer here. Well, okay, I admit it. Maybe it's my fault too. He goes on to talking about his newfound hobby, returning to something that he used to do, and it's signed, sincerely and with much techie love, Howard in Florida. Thank you so much, Howard.
Thanks, Howard.
And if you want to read this in complete email, go to adafruit.com/blog and just type mailbag with a space. Okay, well, it's time travel time, Lady Ada. Let's go into the time machine. Blah, 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 blah. It's time. Okay, so on time travel, we like to have a look back, celebrate some people and more. And this week, did you ever hear of Thelma?
No. Which song is this?
Thelma Eastern is an American computer scientist, and it was her birthday. Thelma was an American computer scientist and engineer who did pioneering work in the fields of expert systems and biomedical engineering. She's one of the first to apply computer technology to healthcare and medical research. She was a professor at the Department of Computer Science, University of California in Los Angeles. One of the people that aren't in the spotlight, but we try to put the spotlight on these amazing women through computer science and history and more. So check out Thelma.
What's interesting about expert systems, I was actually thinking about expert systems today because I remember when I was first learning programming computer science, there were a lot of books about expert systems that were written in the 80s and 90s. And people don't talk about expert systems anymore, but if you look at, Watson and other, AIs, a lot of them are not that much more complicated than expert systems with heuristics.
Yeah. Deep Blue.
Yeah.
Okay. So that was that.
Okay.
Next up, we are celebrating African American History Month all month long on the blog. Check it out on adafruit.com/blog. And what's kind of cool is we have a time travel post too. And this is Katherine Johnson, mathematician, recipient of the highest medal and award you can get as a civilian in the U.S. You'll see. And because this is NASA, we have a video, and we can play NASA's video inside of our show. So we're going to show this video now.
Also in a movie right now.
In a movie right now.
Yeah.
So it's really neat.
Nice.
Check out the makers.com video and footage with some of her words and more, and artifacts artifacts
Artifacts and
on this
facts.
historical journey. So
Okay.
let's play this video.
This is the story of a space scientist, a mathematician, a physicist, a pioneer. In May of 2015, graduating students at West Virginia State University reflected on a trail that had been blazed for them by one of the university's most accomplished alumni.
NASA and West Virginia State have something very important in common. Our legacies are woven together by a remarkable pioneering American by the name of Katherine Johnson.
On November 16, 2015, the White House announced that President Obama will be awarding Katherine Johnson the Presidential Medal of Freedom, our nation's highest civilian honor. In their official announcement, the White House cited Katherine's influence on every major space program, from Mercury through the shuttle program.
During her remarkable 3 decades at NASA, Katherine calculated the launch window for America's first human spaceflight. She verified the calculations for John Glenn's historic first American orbit of Earth. She calculated the trajectory of Apollo 11's flight to the moon and worked on the plan that saved the Apollo 13 crew and returned them safely to Earth. A native of White Sulphur Springs, West Virginia, Katherine's intelligence always outpaced her age. As a young child, she used to follow her older brother to the 2-room building where he went to school. Her brother's teacher was amazed at her ability to read at such a young age and invited her to attend summer school. Thus began a remarkable path of learning and discovery.
I was always around people who were learning something. I liked to learn. You learn if you want to, so you've got to want to learn.
Katherine enrolled in high school at the age of only 10 years old. She would often walk home with her principal after school, and he'd point to the constellations of the stars in the sky. Katherine never stopped looking upward or reaching for new heights. Even in the face of personal adversity, Katherine was determined to follow her dreams. In 1953, these dreams brought her to NASA's Langley Research Center.
Originally, Katherine was hired to join a team that was nicknamed Computers Who Wear Skirts. But when the opportunity came to help out the all-male flight research team on what was supposed to be a temporary basis, she seized it. And so impressed her male colleagues, they chose not to send her back. She would stay at Langley and with NASA until her retirement in 1986.
I didn't feel the segregation at NASA because everybody there was doing research. You had a mission and you worked on it, and it was important to you to do your job.
Katherine Johnson helped write the first textbook on space, and today she continues to rewrite history through an enduring impact she has had on space science, civil rights, and gender equality. When Katherine Johnson's mother warned her that she was moving to Virginia during a tough time in American history for Black women and men, she responded, "Well, tell them I'm coming." She helped lay the groundwork for our journey to Mars, so future generations of explorers will also be able to say, "Tell them I'm coming."
Okay, next up in some news, there's Infimakers. Check out the post on our blog. They're giving away tons of money to make stuff, and it's from some of the folks that we knew from our White House visit.
Oh, this is the project that they started.
Yeah,
Oh, cool.
and so check it out. One thing that's interesting, and I'll have a follow-up article later, you and many makers who are making an impact in the world and a change received an award from the White House. We have a thing from the president, and I have a pin, and we have all these things. And
We got a Sharpie.
Yeah, and all of so you were on the whitehouse.gov site, and
Yeah.
it's been completely deleted and removed.
That's right.
But luckily, it's on archive.org, and we have a backup copy. But it's interesting because all of those champions of change, all those makers, did a lot of amazing things, and hopefully there's going to be a spot where people can link to it again.
Yeah.
But we have a physical thing that was signed by the president.
I'm also just doing it for doing it. I don't care.
You know, Bob Marley and I think Orson Welles never got an award.
Hitchcock.
And did it make their art any less? No. Okay, next up. The MIT Bootcamp is going on. We have a link to that, and we're getting the word out. If you like to do IoT stuff, MIT has something coming up. So those are the things that we wanted to mention in the event world.
Yeah, if you have small computers and big problems, microcontrollers to do all sorts of cool electronics and science. We didn't really have microcontrollers when I was at MIT. I mean, we did, but they kind of sucked. Now they're really good. So check this out.
What
It'll be fun.
the programming language that you had to learn was Lisp, right?
Scheme.
Scheme, okay.
They don't do that no more either.
Wow.
Python.
And this is one of the many reasons that we are making CircuitPython. Okay. Next up, I have a time travel that's a little different. So 8 years ago, we were in a tiny apartment. We live in a tiny apartment now, but we were in a tiny apartment. And
With boxes.
And we made a video called Citizen Engineer. So this is just a 1-minute snippet that I wanted to share with folks. And this was 8 years ago.
Oh, okay.
Hey, Lady, whether you like it or not, you're an open source hardware company. So we have some open source hardware news, and we have a lot of examples of open source hardware in our learning system.
And we have a ton of guides this week.
1,171. So
yeah, we really
talk about
guided it
these,
up.
and then I have some videos that you can show. But what guides were there this week?
Actually, we have a lot. So yeah, thanks for having them all here. So we have the Bluetooth LE MIDI controller from last week. That was last week's 3D Thursday, so that guide's up. We also have that level shifting 3.3 volt microcontrollers and NeoPixels guide, a really handy one-pager from John Park, everything he's learned about it. Adafruit IO Basics analog input, Adafruit IO Basics color, Adafruit IO Basics analog output, and Adafruit IO Basics temperature and humidity, and Adafruit IO Basics servo. So 5 Adafruit IO Basics tutorials by Todd Treese, who's spearheading Adafruit IO, doing a lot of work with that.
And we have, just some videos that you can see of the interaction between microcontrollers, our iOS app, our Android app, and of course, lots of physical computing using the thing we like to call internet.
Yeah, and these are just really good, core basic guides. People just look, I just want to turn on and off an LED, or I want to move a servo remotely. So we now have really good step-by-step guides using the Huzzah, which is our most popular feather, and a whole bunch of different sensors, outputs. I mean, this, once you get good at this stuff, you can, of course, adapt it and make the project you want. But these are like building blocks. We also have a tutorial about the Circuit Playground motion sensor from Aaron St. Blaine, which you saw a video, covered a little bit of that. The DIY Lego LED bricks from Noah and Pedro, that's this week's 3D projects. And then Aaron also emailed us, and she said in the middle of the night she really wanted to do a Circuit Playground fiber optics project, and she couldn't go to sleep until she did it. And so there's a project showing how to 3D print a shape so you can attach fiber optics, which is a really good idea, because if you have fiber optics, this can be a nice way to drive a whole bunch of them for your cost. She loves fiber optics for her projects, and that's the guides for this week, so that's quite a bit.
Okay. Amazing. All right, next up.
Amazing.
We have adafruitdaily.com. It's our spam-free newsletter. We do something every day. We have 3D printing, we have electronic tips, we have cosplay, we have wearables, we have maker business, we have MicroPython. This week, this is kind of neat. We had a micro business post. The former, which I guess you're always the co-founder of something, the co-founder of Arduino, Gianluca, is now doing an IoT company.
Yeah.
And they have a Kickstarter. So we backed it because why not? And then you can see it's an Arduino compatible that does IoT stuff. So we're following the story, and it'll be interesting to see if this is an Arduino competitor. Is it something that extends Arduino? It uses shields, and in the Kickstarter video, they have all of our shields and shows how to use
What's
this stuff.
interesting is it's like the Arduino people are starting to make Arduino killers on their own.
Yeah.
You know.
Okay. Next.
I got no other comment.
And it just brings
have no words.
It brings up a good thing. So I'm the founder of Hackaday. I guess that's always true. And I don't do anything with Hackaday anymore. I like what they're doing with the site. One of the things about the site is if you use an Arduino or something, someone might complain, but Sparky, the blue smoke monster, has some tips for you.
Oh yeah? Let's see what he has to say.
Alright kids, here's the deal. Posting up your projects on the internet, don't worry about people complaining and saying, don't use Arduino. The worst thing that can happen is you'll see me as Sparky the Blue Smoke Monster, and that ain't so bad.
Okay.
Thanks,
So
Sparky.
next up, we have some made in New York City manufacturing. This is our selective solder machine. Looking around for things to solder. Hey,
Hey, gotta solder you.
I want to solder this.
I'm
I want
soldering
to solder
this.
that, and I want to solder that.
Okay,
and it
this.
finds a path.
Ooh, gonna solder.
And then let's
that
see what it's doing.
way.
Woo, look at it go.
Fun.
It's like
Boom.
a T1000 dancing.
What is it making? Like feathers or something? I don't know exactly.
We are a feather factory.
Yeah, I don't know exactly what it's making there. But it is soldering them.
Yeah.
Nice work.
So you can check that out. We also, as part of our Made in New York City series, you can see
Oh, that's some nice angle.
circuit
action.
playgrounds
Bam.
going from the board loader into the Samsung 482 and 481, placing over 40,000 components per hour.
This is so cool.
We also have a little bit of rework.
It happens. Sometimes they come through the selective machine and they're a little over soldered.
And then here's us soldering some LEDs. And you know what they say about diodes? Don't say it. Sparky will.
Hey! You know what they say? Every diode is a light emitting diode, but sometimes only once.
Okay, we have some...
Lots of wisdom there.
What?
Lots of wisdom there.
Yeah, Sparky is on fire, literally. Lots of IoT news this week. Adafruit IO is our beta service. We'll probably have a pro pay model. We just want to make sure it's the best thing possible. We'll also have a free model. So stay tuned for that. But Adafruit IO is where you can go online and do all sorts of bells and whistles and knobs and maps and more. Save your feeds. Do anything you want. It's your data. We have an Internet of Things Bill of Rights. And this week, guess what, Lady Ada? We're up to 63.5 million inserts of log data in the last 7 days. 23,600, not 600, 300, sorry. 23,365 users. 18,000 online feeds.
It's almost twice as many as when we first started. I remember when we started this,
63,000 feeds total.
it was about 9,000.
100 inserts per second via MQTT and 15 inserts per second via the REST API. It is going good. Okay.
Is it on fire?
No, that's Sparky.
Sparky, okay.
Don't forget,
Sorry.
Sparky's on fire. Okay, 3D printing. Noah and Pedro, as you probably saw in the show and tell, or we talked about, had a really neat project. We have a few this week, and take it away.
Lego my ego.
That's next video, not this
Oh,
one.
sorry.
Yeah. This is Biel Mamidi.
Bleed. speed round.
Yeah, and in case you have flexing material and you're like, I really need to make a pair of pliers with this, we got it. Okay.
Kind of weird tool.
And you were waiting for these as Lego.
Okay.
This is light up Legos.
I want the Lego one.
Lego my video.
Lego my Lego.
In this week's project, we'll show you how to add LEDs to your Lego bricks. These light bricks are 3D printed and have tiny LEDs inside. They're pretty cool for adding lighting effects to your scenes, and you can easily connect them to just about any Lego compatible brick. You can make them in several colors and turn them on with a tiny button on the side. Compared to the official light bricks, these diffuse the whole brick instead of just being a spotlight. The Lego light bricks are great for pointing light, while the 3D printed brick glows brighter and fits in tighter spaces. But you can connect them together to make interesting combinations that illuminate your projects. You can 3D print the bricks using opaque filament on almost any desktop 3D printer. But if you don't have a 3D printer, the files are free to download, so you can send them to a 3D printing service. The two pieces take about 10 minutes to 3D print and only cost a few cents in material. You can get the full list of parts to build this project from our tutorial linked below. Here's how the circuit works inside the brick. The LED sequin is housed between two walls. Two coin cell batteries are wired in series and powers the LED. A push button will open and close the connection between the batteries to turn the LED on and off. When the button is held down, the LED stays on, and when it's released, the LED turns off. These Adafruit LED sequins come in a pack of 5, so we'll need to break it away from the panel. The LEDs are surface mounted to a PCB and already contain a current limiting resistor. We'll work on the bottom of the LED and tin the positive and negative contacts with a bit of solder. The 3D printed brick requires support material, so we need to carefully remove it. A pair of flat pliers are great for pulling out individual layers of the support material without damaging the brick. Next, we'll need to cut pieces of wire to connect the LED to the batteries. We can use the brick to gauge how long they need to be. They'll need to be pretty short to fit inside the brick. These red and blue colored wires will help tell the connections apart. Using wire strippers, we'll remove a bit of insulation and tin the tips with a bit of solder. We'll need 4 pieces of wire to connect all of the components together. We'll use copper foil tape to connect the wires to the batteries. We'll cut thin slices using a pair of scissors. Then we'll tin the pieces of copper foil with a bit of solder and attach a wire. We'll need to do this for the positive and negative contacts. Next, we'll need to trim the pins on the button short using a pair of flush snips. Then we'll tin the pins with a bit of solder and attach one wire to each pin. Make sure to keep the backing on the pieces of copper foil tape. Now you can connect the wires to the positive and negative contacts on the bottom of the LED sequin. They should be in an upright position. We'll need 2 more pieces of copper foil tape for connecting the wires from the LED to the batteries. Remove the backing and place them on the inside of the 3D printed brick and stick them to the walls using a pair of tweezers. Then carefully tin the 2 pieces of copper foil tape with a bit of solder. Next, we'll insert the LED sequin into the 3D printed brick face down. Position the wires from the LED towards the 2 pieces of copper foil tape. Now we can solder the wires from the LED to the copper foil tape. Insert the wires from the button through the opening on the outside of the brick and press it down until it snaps into place. Now we can position the copper foil tape so the positive and negative wires follow our circuit diagram. Then peel the backing off from the copper foil tape and stick them to the inner lining of the brick. Next, we can insert the coin cell batteries. Orient the batteries so the positive and negative contacts line up properly. Now when we press the button, the LEDs light up. To finish this off, we'll secure the bottom cover using a single machine screw. And that's it. Now we can try it out and add it to any LEGO compatible bricks. You can connect it to a number of LEGO bricks from either the top or the bottom. To keep the LED on, you can place a brick near the button actuator and snap it in place. These transparent pieces are great for this and look really nice with edge-lit material. These LED bricks look great on buildings, but they can also add lots of details to vehicles and other props. We hope you like this project and try it out for yourself. Thanks so much for watching, and don't forget to subscribe to the Adafruit channel for new DIY projects every week.
Okay, and we also have a little bit of footage from their build. So that's the 3D printing we have this week. Don't forget, every Wednesday morning, Noah and Pedro do 3D Hangouts. And I would be remiss without mentioning Marigold's the code tonight, Lady Ada. 10% off in the Adafruit store. And you know what time it is.
Is it?
Do your song.
New.
Okay, Lady Ada, we got new products.
Yeah, we have a bunch of new products.
What do you want to show?
Let's start off with this. It is a TO92, but it's not just any TO92. It's the. Can you go back one?
Yeah.
Next one. Next.
This one?
Yeah.
You like this one? Okay.
Well, it has the part number on it because I can never remember. It's the KA75330.
What is it?
I'm glad you asked because I'm ready to tell you. It is a power reset controller. It's a little chip that lets you make sure that your microcontroller or project or microcomputer doesn't turn on until the voltage on the power input is high enough.
Is it like Transistor Person?
It's kind of like a transistor person, but it's more like op-amp lady with a band gap voltage reference and a divider.
I know her.
Yeah. So what happens is on the first pin, that's like the input pin, you connect that to your power supply, so like battery pack or whatever. And then the second pin connects to ground, and then the third pin is the output. And if the first pin is under 3.3 volts, then the third pin will be connected to ground. And so that basically makes sure that if you have a project with an enable pin and it doesn't run well under 3.3 volts, it'll keep the chip reset until that voltage gets above 3.3. This comes up sometimes. What happened is a couple people in the forums were having an issue, and I was like, oh, this is an easy fix for it. If you have like a Feather Huzzah or like a Wi-Fi chip, and it's powered off a battery, and it runs the battery all the way down, when you try to recharge it, you'll charge up the battery just enough to turn on the chip, which will then connect to Wi-Fi and start doing all this stuff, which will then drain the LiPo battery before it starts getting charged. So it never quite gets charged enough. It kind of ends up discharging it before it gets enough charge to get out of the trickle charge state. So this is really good if you have something that can run a battery down and
Yeah.
uses a lot of power. It might end up discharging the battery again before it gets up to a reasonable level. So this gives it some breathing room. It
Okay.
can be used for a lot of other things. Also, helps maintain stability. If you have electronics that, the voltage levels or the analog readings would be incorrect if the voltage was under 3.3 volts, this will also help you because it's a nice little
Yeah.
reference.
I have googly eyes, but I didn't put them on these. Okay,
Thanks.
next up. So you have a arcade pack, Lady Ada.
Yeah, we do. We
You like arcades.
We have the arcade bonnet, and so we have a couple projects and guides about how to connect, buttons and joysticks directly to a Raspberry Pi, and you can do that. But we also have a couple projects where you might want to have like a Pi Zero, which doesn't have audio output, or you might want to use analog joysticks, which I'll show in the overhead. These are
Okay.
joysticks that are not switch type.
I'll go to the overhead.
So, sorry, this was over here. So, for example, if you want to use a joystick that's analog style, has potentiometers, you need to have special circuitry that takes that analog voltage and converts it to a digital voltage with some hysteresis so that you don't get like weird jittery effects. And so we designed this bonnet, which I will show here. And you don't have to use it on a Pi Zero. It works great on a Pi 3 or a Pi 2 or whatever. It's just really compact. And I have it here connected up to like everything, which is why there's a lot of wires.
Everything.
But there's 6 arcade button connections, and these are like quick connects. So they're very nice. You just snap them right onto your buttons. So you plug in these quick connect cables, and you get 6 buttons, which we found is a really good number. We also have a connection for a joystick. So these 5 wires go to the joystick connection, which is a normal switchy type joystick, which is like this, this clicky type joystick. And then we also have the analog joystick part, as I mentioned. So this is the analog joystick, and you can connect this up to a joystick like this, and it will do the proper conversion to digital switches for you because it has to like do 2 comparators. So that's that circuitry here. And then over here we have a 3-watt speaker output. So you can connect up to a 3-watt speaker and it will do the audio output, really nice digital clean sound. So, on even something like a Pi 3, the audio output can be kind of scratchy. And if you want to drive, if you don't want to have to like get a separate audio amplifier, this is a nice I2S digital all-in-one, speaker decoder amplifier, which can give you really good quality audio sound. And all of the digital inputs here go through a GPIO converter. This little chip here is an I2C GPIO converter. And the reason we did that is we wanted to have 14 of these inputs, 6 buttons, 4 joystick pads here and 4 joystick pads over there. But we didn't want to use all of the GPIO pin on the Raspberry Pi. We actually leave almost all the pins available. And this means that this can be used with stuff like a Pi TFT, or if you have some other kind of hat that's using a lot of the connections, you're not using all those connections up. And if you really want, you can also stack 2 of these together so you can have 2 controllers worth by setting the address pin. So it's kind of like we wanted to make something that was good for very compact builds and also allowed you to use a Pi TFT at the same time. So I thought I just show a little demo.
Yeah.
What's neat is we have a little Python script that converts all of these switches into key presses. So
You can hold up the display underneath there, yeah.
yeah, I know. It's just a little complicated.
I ran out of HDMI inputs.
I know. No, it's fine. So I've got this controller here. Let me turn this on. Hopefully I didn't reset it. Uh-oh, I might have reset it
Beep, beep.
by accident. Oh yeah, I have to.
Okay,
reset
well,
this.
we'll come back to that.
Whoops, I unplugged it.
We'll come back to it as it boots up, okay?
Yeah, 1 second. Yeah,
All good.
we'll go back.
Yeah, totally.
I
Totally.
I kind of unplugged the
All right.
USB by accident.
Well,
Okay, so this is going.
next up. What else we
Next
got?
up is the Pi hat to the right.
This one?
No,
This
keep
one.
going. Keep going.
This one?
Yeah, that.
Okay.
Okay, so next up is this e-ink hat. While my Pi is booting, RetroPie is happening. So this is a nice add-on. It's like the big sister to the Pi Zero version of this e-ink hat. It's called the Papyrus. And it's got a nice, it's like 300 by 120 pixel e-ink display. And what's really nice is I'm holding it up, and you see there's no power. So it keeps the display on the e-ink working even when it's unplugged. That's one of the things about e-ink that's really nice, is it's daylight readable, and it doesn't use any power. So that's pretty cool.
Okay.
And this works with any Raspberry Pi. It works best with a Pi 2 and Pi 3 and B+, because it's kind of big. We have a Pi 0 sized one as well. And this one even has a real-time clock, and it has all these buttons and add-ons. It's really easy to use, comes with a library, and you can display black and white graphics and text. So you can see the bottom here. There's all sorts of there's a real-time clock battery, and there's optional buttons you can solder in, and little plugins, and it even has a little pogo pin that connects to the reset, so it looks like it can control the power on the Raspberry Pi as well, or maybe reset that when necessary.
Yeah, make your own tiny Kindle. Okay.
A little,
Next up.
Okay, so this is back to. You want to go back to the demo?
Yeah, sure. Let's go back to the overhead.
Okay. So
Hey, look at us. We're playing video games.
Yay! So we got this. So you know what you could do? You could help me by holding this.
Yeah, this is my job.
Man, this is very hard to. Okay, so
We did playing video games. Beep 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 beep
see.
beep. She's not doing engineering right now. She's playing video
no,
games.
but I have to.
I got it.
You got it?
Yeah, I'm tilting it so people can see what's on the screen.
Okay, so let me play.
What do you want to play? I got this. I wanted to. Nintendo Presents. Okay, now you got it. You
Yeah.
want it.
No, I'm just
This is what it's like at home. She never lets me play video games.
It's difficult. Hold on. This has a clampy thing.
I'm just saying, I think I could bring a lot to the video
Okay,
games.
you try holding it now. I was just trying to make it so it wasn't reflecting the light as much.
Okay.
Okay, thank
I'm
you.
a helper.
Wait, hold on.
Watch out.
Okay.
Watch out.
No, I had to figure out which one's the button. Okay, so you can play all sorts of joyful games.
Ooh, watch out for the bomb.
You can get hit by a bullet.
Someone sent you up the bomb. Okay.
All sorts
did
of
it.
fun things. So basically you run RetroPie, and it works with RetroPie just fine. Pi 3 will get you the best emulation, but you can do Nintendo, original Nintendo and MAME quality emulation on a Pi 0.
Game's open source now. Okay.
Pi 3 will get you the better quality stuff,
Okay, and then you wanted to
Nintendo
show this.
64. And this is the bonnet itself. So this is what it comes with, and you have the 6 connectors. It comes with a little kit. You can solder it together and plug it onto your Pi, and then just run our installer script, which will add the audio output and the little keep button press to keyboard press input.
Okay. And then tonight, the star of this show,
Yeah.
besides you, is this.
It's so small and cute, but it's the star. This is a I2S microphone. It's the SPH0645, which is just the model. It's a good wide range I2S microphone. This is a digital only microphone. So if there's some, if you're using a simple microcontroller, you can usually just use an analog input and, get the microphone into the analog input and then just read it with an analog read or something. But if you have a more advanced microcontroller, or if you have a microcomputer like the Raspberry Pi, it doesn't have analog inputs. Instead, you're expected to get your microphone input using I2S, which is an audio standard. And this is one of those microphones that you can use with, say, the Raspberry Pi or the SAMD. So it is a bottom port. So you see that silver thing in the middle that's a microphone. On the opposite side, you have the port, and that's where the audio comes out. So you're kind of expected to use this upside down, as it were. It's also 3.3 volts only. You can use it with 1.8 volt logic, but almost everybody's going to use it with 3.3. So use it with 3.3 or what have you.
Yeah.
And personally, I think it's mostly for the Raspberry Pi. You can use it with the SAMD processors, but they also have analog inputs, and it's usually easier just to do analog than I2S because it's a little bit more complicated. You have to set up DMA, and you have to buffer all the data at once.
Okay.
But I do have a very simple demo of it running with a Feather M0. So this is a SAMD chip, and the SAMD processors have an I2S interface, and there's even an I2S library. So let's see. So this is just a simple demo. You know, when I tap it, basically gets louder. Testing. So that's, you know, just
That's
simple
cool.
audio VU meter. And I have an example code for this in the library, but it's digital only, right?
Okay.
No analog. This microphone is mono. You only get one channel because it's only one microphone element,
Yeah.
but you can wire up 2 of them. Not on the Arduino library, doesn't only supports mono, but on like the Raspberry Pi, you can use 2 and then you get left and right, so you get stereo.
Yeah.
You just get 2 of them and you wire them up together, and actually I2S is kind of smart. It will be like, oh yeah, you have 2 microphones, like sweet.
Okay. And with that, Lady Ada, congratulations, you've completed the new products. You did it.
Yay!
Okay, everyone. Well, we're going to do, it's not out yet, don't ask, but first, the code is Marigold. That stuff you saw, you can get 10% off. To the vault. To the vault.
Yeah.
To the vault.
Whoa, I got a PlayStation emulator on here too.
Whoops. That's not the vault. Inside the vault, we have the trivia question. But first, we're going to open up the vault. Okay, what's top secret?
I have this cute little bonnet because I was working on this arcade stuff, and I was like, well, you know, maybe I could just make like a little thing that plugs into a Pi Zero, and it has like the little mini thumbstick that we recently got, some buttons. It's kind of cute. You just like plug in HDMI and power, and like
This is the cutest thing I've ever seen in my
it's
life.
super cute. And we're gonna do like some silk screen. This is just a prototype I
Wow.
put together.
I like the matte black PCBs.
Yeah, everyone likes it, but you know, it doesn't look as good when you.
No, it's like the matte black cars don't. It's a good idea.
It looks good, and then like if you
It's
get
like-
even a little dirty, it's really
It's like
noticeable.
a driving around on a chalkboard.
Yeah.
Okay. So that's the top secret.
Feels nice. Yeah, it's got that nice matte
Okay. Back in the vault with you, secret product.
Yeah, it's not out yet.
Okay, so we're going to do some questions in the chat, then we're going to get out of here. We're going to run a little bit late tonight, but it's okay. The questions, Lady Ada.
Yeah, I'll take them while I play Crash Bandicoot.
Yeah, let's do speed run on these. Okay, Feather only has one analog pin. If I have 2 temp sensors, I have to go with digital / one wire. Not much info on this, no tutorials. Or do I use ADC?
You can use external ADC or one wire, or you can use I2S temperature sensors. Yeah, it's a trade-off. If you have like an ESP266, you don't have a lot of analog inputs.
Okay. Special thanks to Eric in the Twitch chat who helped out someone who was doing electronics projects. Thank you, Eric. A lot of that was answered in the Twitch chat was stuff that's kind of better just, typing and making suggestions to some things to try involve NeoPixels. That's one of the cool things that's happening with all of our shows is the people in the chat help each other because we're doing 5 streams at the same time. So thank you, everyone who helps in the chats. And, you're excellent to one another. So that's why we do this.
Got some cool cosplay going on there.
Yeah. Okay, next up. What is the license for the tutorials? I want to translate at least a couple circuit Python, once Spanish. Yeah, you can go ahead and do that. We're going to have translations of all of them eventually. But go ahead and do it. Just send us a link so we can tell people where they're at. Next up, of course, credit and link to us. Assume it's a Creative Commons share alike in some way. All right. Okay. The quick little disconnectors on your button demos, what are they called?
They're called Quick Connects.
Okay.
That's the name.
All right. Let's see here. We're speed rounding here. Why is desoldering so hard?
This is hard to undo things in life and in soldering.
Okay. Do you think the beagle bone is a little hard to set up?
Yeah.
Yeah. Yeah.
No, all Linux,
you're
all
not the only
Linux
one.
computers are kind of hard to set up. BeagleBone's hard to set
Not
up
the only
too.
one, Andreas. Okay.
And there's not as many tutorials on it too.
Okay. Any idea why Arduino is an old GCC version with no ability to use a C++ standard library?
They do update it, but it's usually whatever AVR GCC is, and
Okay.
they try to keep up. But it's also whenever a GCC updates, there can be bugs, there can be incompatibilities. So Arduino tries to go for max compatibility, and sometimes that means running an older version.
Okay. Why does the MCP 23008 Arduino code cause my Feather 32 RM6HWC to lock up?
I don't know, but you're gonna have to figure it out step by step. Are you waiting for an interrupt? Are you clouding on a pin? Do you not have pull-ups
Yeah,
on
will there
I
ever
squared C?
Oh, sorry. Will there ever be pin expander for Feather boards?
I don't know. I mean, we have pin expanders in the shop. It's kind of better just to wire up whatever you need.
What are the compressors that we use here? We have a couple. We use them for the pick and place, the board loader,
Selective solder
the
machine,
selective solder machine,
hydraulic stuff, a lot of
the
hydraulic in there.
nitrogen generator, all those
Yeah.
things.
They need air.
Air fuels us.
Compressed air.
Who's Adafruit Industries? Her, right
Me.
there.
Hi.
Okay. Any chance of making a Fona Featherwing or Fona M0?
Could be. Not out yet. Dunno.
Hmm.
No ETA.
Okay. Those are the questions tonight. If you need anything more, chat with each other. And, of course, post up in our forums, forums.adafruit.com. Tomorrow morning, 11 to 3, we're going to be upgrading forums, so it might be a little bit of downtime.
But it's all good.
It's all good. Okay, so Lady Ada, let's do a trivia question.
Okie doke.
What are the rules, Lady Ada?
Rules are you can only win once per lifetime. So if you have won something before, please sit on your hand or go make yourself a sandwich and let other people win a fabulous prize.
What's the prize tonight?
The fabulous prize tonight is going to be an arcade bonnet.
Really, an arcade bonnet?
Yeah.
Wow. Okay. Well, this is going to be a pretty easy question if you all paid attention to the chat tonight. Pretty easy.
Yeah.
Who was the American computer scientist and engineer born in 1912 that we celebrated? She was a computer scientist and engineer who did pioneering work in the fields of expert systems and biomedical engineering.
Expert systems.
Yes, if you go to the blog and you search for time travel, you'll be able to read this. So all you got to do is type who it is. Oh, the question about nitrogen generation, you use that to have a stable atmosphere for the selective solder.
Yeah, the selective solder, it has flux, but it's still pretty dirty, and it's hard to keep that area clean, so it uses nitrogen, so it's a non-oxidizing environment.
All right, congratulations, Lincoln Roth, you got it. Thelma Estrin, congratulations.
Thanks.
So Lincoln, email support@adafruit.com, and what you're going to say is, hey, I won the chat, my name is Lincoln Roth, and what is the PID?
3422.
Okay.
So if you have a Raspberry Pi, it will go well with your Raspberry Pi.
So email support@adafruit.com, Lincoln, and just let them know that you won, and we'll send you out the bonnet. That's the show for tonight, folks.
Crash Bandicoot time.
If you liked the things you saw on the show, use the code Marigold. You're supporting us, an open source hardware company with all these cool people. And we do this every week for you. For you. And Lady A is going to play video games and not talk to me for a few hours.
No.
You'll say, get away.
Get away.
I'm playing video games. No, it's fine.
It's pretty fun to play some of these games. I haven't played Crash Bandicoot in a long time. It was a really good game.
Yeah. I noticed when Lady Ada plays video games, she goes into another place, and then later on electronics come out.
Yes.
I think it's like your downtime.
Yeah.
Yeah. Okay, folks. Well, that's it. There's a special message from Sparky.
Another one?
Yeah, that he wants to say.
Okay.
Don't read the comments. Don't read the comments. Don't read the comments. Don't read the comments. Don't read the comments.
And with that, everyone,
Thanks, Sparky.
we're going to give you a picture of a cat.
Meow.
He's at home on a little heating pad, meowing.
He's
waiting for
very
us.
happy.
Yes. Here's your moment of Zener. That is it, folks.
Thanks, everyone.
Yeah,
Good
we're on
night.
Snapchat, AdaBot, by the way. We do a lot of behind-the-scenes things, too, there. Bye.